What's up? We're talking about related rates today. Related rates is an application of implicit differentiation. All right, so we're taking what we know about implicit differentiation and applying it to word problems now. And the biggest thing is when you receive a word problem over related rates, right, you need to figure out what you know, you need to figure out what you're trying to know, and then you need to take the derivative. Right? It's not really any harder than that. So there's some stuff here that you can read, but we might as well just jump into some examples so that you can see what's going on. All right, so we're given a function, okay, and it's saying find dy dt given this stuff. All right, and that's kind of weird, but in related rates, because they're application problems, we typically differentiate with respect to time. Usually something's changing over time, and we need to relate the different rates that we're given. That's why it's called related rates. So we're kind of relating dy dt, so this function y over time, to this function x over time. Okay, and usually it'll happen at like one instant, which is why we have to use derivatives. Anyway, so given this, I know all of this stuff, so I'm trying to find dy dt. Right, so usually what I do is I write all that stuff out. So I want to know dy dt. I know that when x equals 4, dx dt equals 2. And it says it twice, which is weird. Anyway, so let's take the derivative. I know the derivative of y is dy dt is equal to the derivative of 5x squared is 10x dx dt, right? Because x is not our variable in this case. X is a function of t. So we have to use chain rule, right? Minus 6 dx dt plus 2. Okay, now we can plug in numbers. So we're always going to plug in our values after we take the derivative. You cannot plug it in before because then we haven't dealt with any rates yet, so you can't plug all this stuff in yet. Okay, so we're trying to find dy dt. So I know x is 4 and dx dt is 2, and I'm just going to plug in those values. Right, and we should get that dy dt equals 68. Okay, I don't have any units, so I don't have to include that, but normally we would want to include our units. This is my final answer. Alright, let's keep going. Okay, so here's a pretty typical example of what you'll be given. All right, we know that a balloon is being inflated at a rate of 10 pi feet cubed per second. Right, and we want to know the rate at which the radius is increasing when r equals 2. So this is like 1 split second in time when the radius equals 2. And we want to know the rate at which the radius is increasing, meaning I want to know what dr dt is. Right, this is the rate at which the radius, so dr, is increasing with respect to time. Okay, there's a couple things that I know here. So I know that the volume is changing at a rate of 10 pi. The reason why I know it's volume is because it's feet cubed. So I know that dv dt is equal to 10 pi feet cubed per second, and I know that my radius equals 2. Okay, so they give me this volume equation. So what we're going to do is take the derivative of this volume equation. Okay, the reason why is because we're relating how volume is changing to how the radius is changing. So we're going to use this equation, take the derivative, and that will relate the ideas that we're trying to. So the derivative of v is just dv dt. Right, and this is all just one thing here. Now, 4/3 pi is just a constant, so that's just going to chill. Right, and when we take the derivative, the 3 will drop down and cancel here. So I have 4 pi r squared, and then times dr dt. And dr dt is what we're trying to find. This is how the radius is changing over time. Okay, I know that at this 1 split second, I know that I have some values here. I know that dv dt is 10 pi. I know that r is 2. At this one instant in time, these things are true. Well, actually, this is true for the whole thing, but at this one instance in time, the radius is 2, and I'm trying to find dr dt. All right, so we can just divide. Dr dt is equal to 10 pi divided by, and we can multiply this out. So 2 squared is 4 times 4 is 16 pi. The pi's will cancel, and we can reduce this. So that'll be 5 over 8. Okay, and for units, it is feet per second. All right, so I know that the radius is increasing at a rate of 5/8 feet per second when the radius equals 2. All right, that's what I just found out. All right, so that's it for our notes today. I'll see y'all later.